Hey everyone, welcome back. So in the last video, we covered the basics of Java threads. We saw Java threads in action, how to start a thread, how to create a thread. Now in this video, we will cover some of the commonly used methods which belong to the thread class. So let's see what we are going to cover in this video. We will cover these 5 methods starting with Thread.currentThread. Then we will see how sleep works, what is the purpose of isAlive, how do we use the join method, and in the end, we will cover the last method to catch uncaught exceptions in a thread. So without further ado, let's get started. So first of all, let's understand how do we use Thread.currentThread method. What does it mean to get the current thread? So we know Java programs are multi-threaded. If you don't create any thread, even in that case, we have the main method. And so we will have a main thread, which continues its execution in a linear fashion. Now, when we create a new thread from the main code, it will actually create a new thread in parallel. So let's name it thread1. And similarly, main method can create more threads. So for example, there is one more thread which was created. Now we have 3 different paths of executions which are running concurrently. So suppose in one of the classes, there is a common code, maybe a method which is written, and this method will be used by any thread or any code of functionality. So suppose main can call this method, and similarly thread1 can also call this method. Now, how do we know which thread is executing the code written in this method? Maybe we need it for the logging purposes or something else. But in such scenarios where we need the information of the currently executing thread, we use the method called Thread.currentThread, which is a static method in the thread class. Now this has several other methods, let's say to get the name, to get the priority of this thread and so on. So now what happens if you write Thread.currentThread.x method in this method? What will happen when JVM executes this particular line of code? It knows which thread has called this method, whether it is main or thread1. So it will get that current thread and it will print the information that we have asked for. So maybe if we are printing just the name, and if main thread has called this method, JVM will print main that we will see in the logs or maybe on the console. And similarly, let's say if thread2 called this method, in the logs, we will see the name of the second thread, which is thread2 in this case. So Thread.currentThread method is used to get the information of the currently executing thread because Java programs are multi-threaded by nature. While we are here, let's cover the second method as well, which is sleep. What does it do? We covered the states of threads and the life cycle of threads in the last video, so make sure you watch that one. So what sleep does, it puts a thread into the sleep state. What that means is, suppose there is this main thread running when we executed the Java program. So this is the main thread. And then we created another thread, let's say thread1. So thread1 is running concurrently with main thread. Both of them will try to get the CPU share in order to execute their code. All right, that's how thread scheduling works. Now main is also running and thread1 is also running. Now in some cases, for example, when we want to introduce a delay as an example, or maybe we are waiting for a condition and thread has nothing to do, so we want to keep the thread idle. In those scenarios, we often call the sleep method to put the thread into the sleep state. In that state, thread will not execute. It is alive, but it will not execute. And when thread is out of the sleep state, maybe the time that we have defined is over, or maybe it was notified by the JVM or another thread, basically interrupted. In that case, thread will come out of the sleep and it will continue the execution or it will terminate abruptly. So it depends on the use case. So now suppose we call this sleep method, what it will do, it will put the thread in the sleep state, all right, where it will not execute. It will wait for the time to be over. And when the sleep time is over, it will be put back to the runnable queue where it will wait for the thread scheduler. We have covered this bit in the life cycle of the thread. So that is sleep method of the thread. Then we have the isAlive method. Although you won't see this method much in use in real projects, but it's good to know what it does. We know when we start a thread, it is added to the runnable queue where it will be picked by the thread scheduler, where it will be scheduled on one of the CPU cores, which will actually execute the thread. All right. So while the thread is running, the thread is called to be alive. What that means is in the Java thread, we know we override the run method and we put some logic here. And this is the job of the thread. When the thread runs, it will execute this piece of code. So this is the work that this thread has to do. So while the thread is running and going back and forth to the runnable queue, to the CPU core, until it finishes this piece of code, either normally or abruptly, the thread is set to be alive. So if the thread is currently running this piece of code, maybe it is there, it doesn't matter. While it is running the run method, the thread is called to be alive. And so if we call the isAlive method, it will always return true. And once thread finishes the execution, that means once the run method is complete, thread is called to be terminated or finished. And then if we call the isAlive method, it will return true. So it is used to check if a thread is still running, basically currently running, or it has finished the execution. So this is isAlive method of the thread. Let's move on and cover the next one, which is join method. Now this is an interesting one. Suppose in the main method, here we created a new thread, or before that, let's put a sys out here. Maybe we are printing A, then we created a new thread, which is thread1, and then we are printing something else. All right. Now these SOPs could be any task that main method is supposed to run. It doesn't have to be the log message. It can be actual business logic here. The point is some task or something we are doing before calling thread1 and something we have to do after starting the thread1, right? Now what would happen? We know it will start a main thread. So there it is, main thread. And when it executes this particular line, it will execute a new thread, thread1. And we know these two threads are running concurrently in parallel, right? Now what happens when this line executes? This line is being executed by the main thread. So on the console, main thread will execute this line, and on the console, it will print A. But at this point of time, it will create a new thread. So JVM will create a new thread which will run concurrently, that we already know. But that also means main thread is not waiting for this thread1. Main will continue its own execution in parallel. So it will not wait for thread1 to be finished before it can execute this particular line. It will simply continue and it will run this code. This line will be executed by main thread again. And so on the console, we will see B. All right. And thread1 will continue its execution in parallel. So that's why sometimes we see out of order execution, which is actually valid, which is genuine. Now suppose we have to do something here which is dependent on the thread1. How do we do this? Because there is no ordering guarantee. Main method is not waiting for thread1. So what if we have to block here so that we can wait for thread1 to finish before we execute this piece of code or whatever is written after thread1 line? In such scenarios, we can call the join method. So suppose here, if we call x.join method, what it will do, it will cause the main thread to be blocked for thread1. And that's why the name join. So what would happen? Main is now blocked. It will wait for thread1 to finish its execution. And when thread1 finishes the execution, both threads will be joined here. And after that, main is able to proceed. Main will now continue its execution. So if we notice this time duration, if we observe here in this time duration, main thread is actually waiting because we called the join method. It's not doing anything. It will not execute these lines. Basically, it will wait for thread1 to finish. So in this case, when we use the join method, first of all, main thread will print A, then thread1 will be started. Now main thread will block. It will wait for thread1 to finish. Thread1 finishes its execution, and then only main will continue and print B on the console. All right. So that is the purpose of join method. And the last method was how to handle the uncaught exceptions, and that we will cover in the hands-on. Let's move on. So I have created a new class in the new package day 2, and here we will see all these methods that we have discussed so far. So let's start with the first method, which is the current thread. How do we use the current thread method? We know it is a static method of the thread class. So we call Thread.currentThread, and it returns the thread reference. So we can store it like this. And because it is a reference of the thread class itself, so it has all the methods which belong to the thread class that we have been using so far. So we can actually call t.start, for example, or we can also get the name and other details of this thread, like get name, t.getState, what is the state of this thread, what is the priority, all right? And all these get methods we can use in order to get some information of the currently executing thread. So let's say we also print this state. What else can we do? Then there are some methods like isAlive, isVirtual, isDaemon. Daemon we have not covered, but we will cover in one of the future lessons. So we can check isAlive we are going to cover. So let's use isVirtual. We know it's going to be false because all these threads by default are platform threads. But anyway, let's now run this code and see what happens. What kind of output do we get? So we see the name of the thread is main. As we discussed, by default, there is one thread which always exists in the Java application, and that is the main thread. We have not created this one. JVM has created this one. And this is the proof that there is a main thread. So we get the name main, and the state when this line was executed was runnable. All right. And as expected, t.isVirtual is false because this is a platform thread. Now there is only a single thread, and that's why we see the name of the main thread. But what happens, as we discussed in the theory part, what happens, there is a code which will be called by multiple threads. So let's try to define another method here. And it does something. Dummy method, let's say. And then we can comment this piece of code. What we will do, first of all, we will start a new thread. We will give it a name, another thread. And this is going to be, okay, let's start it right away, and we will pass it a runnable. And in this runnable, we will call the method m like this. And after that, we will call the method m from the main thread as well. I mean main method as well. So what will happen? This method is now being called from two threads. One is the main thread and another one is the thread that we created, basically this thread. All right. So first of all, let's run this code. And we see the method being called twice. But let's say we have to get the information of the thread which is currently executing the method. So what we can do additionally is called by, and then we can use Thread.currentThread.getName like this. Now let's rerun the code. And you see, we see the method logs, like dummy method is called by another thread when this method was called by this thread that we created. And the second time when it was called by the main method, we see the name of the thread to be main. So in such scenarios, when we have to log some information of the currently executing thread, we can use the method currentThread, which will always return the instance of currently active thread. Let's move on and cover the next method, which is sleep. So let me comment this one. So how do we call this sleep method? Sleep is also a static method of the thread class, so we don't need a thread object to call sleep method. We can directly call this sleep method by using the name of the class, like we did here while calling the current thread. So in order to put a thread into the sleep state, we call Thread.sleep. And then we can pass the duration, how long this thread should be in the sleep state. So we can pass the milliseconds or we can pass a duration object. We will cover both of them. Now, important thing is same as current thread, because this is a static method, sleep will put the thread into the sleep state, which is the currently active thread. What that means is the thread which is executing this line will be put to sleep by JVM. So for example, if we put a sleep call here, let's say for 2 seconds, like this, and notice it throws an exception, which is interrupted exception. We will cover interrupted exception and basically the interruptions in one of the future videos. But this is a checked exception that you have to catch or throw whenever you are using sleep method. So in the main method, there is a single line and we have this sleep call in the main method. Now, when JVM executes this line, think about it, which thread is calling this particular code? It is the main thread. So what JVM will do, JVM will put main thread into the sleep state for 2 seconds. Now, there's one important thing, that there is no guarantee that it has to be exactly the same time that we have defined here. It depends on many factors like the JVM implementation, the runtime conditions of the system, the precision of the timing. So it may or may not be 2 seconds in this case. The thread can come out of the sleep state before 2 seconds or before the time that we have provided here. But in the best case, theoretically, this will now put the main thread into the sleep state for 2 seconds. And after that, if we create another thread like this, and let's give it a name, sleeping thread, and we'll start it right away. And we'll pass a runnable here. But before calling the method m that already exists in the main class, let me hide this one. What I want to do is I want to introduce a delay of 3 seconds, for example. And this time we can use the duration object, duration class. So you see it has several static methods, duration dot off, and I can pass seconds, 3 seconds. And it also throws an exception. So here we have to surround the code in try catch block because this is the lambda. Now what will happen when we run this code? Let me put a logger here. And let's put a logger here as well. Starting. All right. Now what would happen when we run this code? We will see the log message right away. Then the main thread will sleep for 2 seconds. So there will be a slight delay before it executes this line because it has to come out of the sleep before it can execute this line. So after a delay of approximately 2 seconds, we will see this log message and then it will start a new thread which will run in parallel. But before it can run the method m, it will also sleep for 3 seconds. So here we are introducing custom delays using sleep method. Let's run the code now. So you see, first we have this starting, then after some delay, it printed going to create a new thread. And then after introducing a delay of approximately 3 seconds, we see the log message twice because once we are calling the m method from here and then from here. That's why 2 method calls. But if I run it again, notice the delays. It is now waiting. It printed this, now it is waiting here for 3 seconds and then it is printing the log messages from the method m. So that's how we use sleep method. Let's move on and cover the isAlive method. So we discussed while the thread is running the run method, the code written in run method, it is considered to be alive. Only when it has finished the execution of run method, it is considered to be terminated or finished. And then isAlive method will return false. So what I can do, let me quickly copy this piece of code and we will comment this one. From the main method, we'll create a new thread and we'll name it alive thread. And what it does, we can remove the second method call. So what this thread does, we know it is sleeping for 3 seconds before calling the method m. And then in the main method, what we will do, we will check that while this thread T is alive, wait. So it will say waiting for thread to finish. All right. And when this thread finishes the execution of its run method, then this condition will become false. So it will come out of the loop. And after that, we will print a log message here, main exiting. So what would happen now after starting this thread? In the main method, we are checking this condition, looping indefinitely. We are checking this condition while T is alive. What that means is while thread T is running this piece of code, either sleeping or running, this condition will return true because thread is alive. And so main method or main thread will keep printing this message that waiting for thread to finish. And once this thread finishes its execution, when it comes out of this block, then this will return false because now thread has finished the execution. And so it will continue and then it will print main exiting, which will terminate the program. So let me run this code. And you see for 3 seconds, it will keep printing that waiting for thread to finish. And after 3 seconds, the thread will call the M method. And that's why we see this log message here. Dummy method is called by alive thread. And when thread T has finished the execution, next time when the main thread checks this condition T.isAlive, it will return false. And so in the end, we see main exiting. So that's how we use isAlive. You won't see many occurrences of isAlive method in a live code, but still it's good to know. Let's move on and cover the next method, which is join. So again, I will comment this out. I will commit this code in a Git repo. Up till now, if you notice, we have introduced kind of a waiting by using the sleep method or by calling the loop indefinitely by checking the status. So here, even though we started a thread here, a main thread was waiting for this thread T, basically the alive thread. So here, even though both threads are running in parallel, but we implemented a sort of blocking or where the main thread is waiting for another thread. There is a better way to do this by using the join method. So what I can do, let's create a new thread. T equals to thread dot of platform dot name. We will name it thread2 start. And in the runnable, same as before, we will put this thread to sleep to introduce a delay, but this time let's make it 1 second only, and then we will call the M method. So by now we know what it will do when we run the code. There is no need to reiterate the same thing, but basically this thread will introduce a delay of 1 second and then it will call the M method. So while this thread is running, we want the main thread to wait, to block at this point. So instead of looping indefinitely by checking the status of the thread, what we can do, we can call the join method like this. So what would happen after starting thread T, main thread will block here because it wants to join thread T. And that can only happen when thread T finishes the execution. So main thread will wait here, and once thread T finishes the execution, it will join the execution and it can then continue by printing the main exiting. It will then terminate the flow. All right. So let's quickly run the method. This is a very simple code. So here you notice first we see the log message from method M, and once thread T has finished the execution, then only we see the log message from the main thread because main thread was waiting here, it was blocked. So that's how we use join. There's one more thing actually. So if you notice, there is another variant of the join method which takes a duration. So suppose you don't want to be blocked for another thread indefinitely. What will happen if, let's say, this thread goes into a deadlock state? In that case, main will keep waiting for this thread. It is blocked. So in certain scenarios, we want to wait, but only for a duration of time. All right, in that case, we also provide a duration of time to the join method. So suppose we want to wait for 1 second, and this thread is waiting for 2 seconds, or maybe make it 3. Now what will happen when we run this code? Main thread will wait for thread T, but only for 1 second. And we know because of this code that thread T will not be able to finish the execution within 1 second. It will keep sleeping for 3 seconds. But the good thing is, because we are using a timed version of join method, it will not block the main thread indefinitely. It will only wait for 1 second. And once this duration is over, it will simply continue. So we will see this log message. And after that, we will see the log messages from thread T. So let's run this code and check the behavior. So you see it only waited for 1 second and then exited, basically printed this message. And after 2 seconds, we see the message from the method M. So that is the behavior of join method. So the last method that we will cover is how to handle uncaught exceptions. Before that, let me copy this thread code, and I will comment this one like this. And then we will create a new thread. We don't need to call method M. We can remove the sleep as well. And instead of interrupted exception, let's cover the another exception, maybe number format exception. All right. And put a log message here, invalid number string found. Just an example, right? And suppose there is some piece of code which is written here which can throw number format exception. So for the demo, we will throw the exception explicitly like this. Something went wrong. And then here we can get the message. So what is happening here? This thread is expecting a number format exception in this logic. Although in this case, we are throwing the exception explicitly, but the point here is it is catching the exception correctly. It is expecting an exception, and when it happens, it is catching the exception by printing a log message here. The idea here is that thread is catching the exception correctly. All right. Then we'll give it a chance to run. So for that, we can actually introduce a slight delay. This is not required, just for the demo. All right. Now let's see what happens. If we run this code, we know when this thread runs, it will throw the number format exception. But because it is being covered here, we see a nice message on the console that invalid number string found, and the message coming from the exception. And then we see the last log message main exiting. All right. Now, what would happen if we throw a new exception which is not handled here? So what I mean to say is, instead of throwing the number format exception, what if we throw illegal argument exception like this? The idea here is that this thread was expecting number format exception and it was handling that. But due to some runtime conditions, maybe the piece of code is now throwing the illegal argument exception, which is not captured here. So what will happen in this case? What will happen when an exception is thrown, but there is no one to handle it? So if we run the code again, we see something ugly going on here. We see a stack trace and then main exiting. And this happened because there is no one to handle this exception. And that's why we see all this stack trace dumped in the logs. So when it happens, let's say, because in a real project, in a real code base, there will be many threads which you will create. And it could happen that in one of those threads, we will probably miss the error handling part. So when that happens, we want a handler that can catch any exception that was not caught by any handler, so that at least we can print a meaningful message in the logs. In order to do that, what we will do, we will now set that uncaught exception handler because it's a static method, so we are calling thread dot. All right. So notice this is an interface. If we check out the code, this is a functional interface which has a single method uncaught exception, and it accepts two parameters, two arguments, thread and the throwable, the exception which was thrown. Going back, now what we can do here, we can for the demo put a log message here that e.getMessage was thrown by t.getName, like this. And we can keep it simple. We can replace this with lambda, and let's refactor it a little bit just for the visibility. All right. So what we are doing here is we are setting a default uncaught exception handler, and this handler is simply printing a log message. All right. This is a static method, so we are calling the method directly on the thread class. And notice this code is not inside any other thread, which means this piece of code will be executed by the main thread. So we are essentially setting this uncaught exception handler on the main thread. Now with this handler being set, let's rerun and see what happens. So now what happens, we know when we run this thread, it will throw the exception, but there is no one to handle it. So it will bubble up to the top of the stack, and it will reach here up to the main thread. But then main thread has this exception handler defined. So this exception was handled by the uncaught exception handler. That's why instead of dumping the stack trace, we see a nice message here that illegal arguments found, which is basically the message coming from the exception, and it was thrown by thread 2 because it was thread 2 which generated this exception. All right. So that is the purpose of this uncaught exception handler that we can set on a thread, which will basically handle all the uncaught exceptions. So that's pretty much it on the commonly used methods of the thread class that we intended to cover. And see you in the next video. Thanks for watching.